Welcome to this ultimate bearing capacity comparison between Terzaghi and Meyerhof. We are going to layer colorful equations, failure zone diagrams, and a full worked example. First, visualize the soil pressing up against a strip footing. The footing squeezes down, forming three colored zones of moving soil around it. This failure geometry is the physical foundation behind both formulas. Now for Terzaghi's fundamental formula for a strip footing. Q sub U equals C times N sub C plus Q times N sub Q plus 1/2 gamma B times N sub gamma. Terzaghi gives fixed adjustment multipliers when the footing is square or circular. Square footings multiply the cohesion term by 1.3 and use 0.4 in front of gamma, while circular use 0.3 in front of gamma. Terzaghi's bearing factors depend only on the soil friction angle phi. N sub Q equals e to the 2 times the quantity 3 pi over 4 minus phi over 2 times tangent phi over 2 cosine squared of 45 plus phi over 2. N sub C is the difference between N sub Q and 1 times cotangent phi, and N sub gamma uses K sub py over cosine squared phi minus 1 times tangent phi all over 2. Meyerhof extended this to account for shape, depth, and load inclination. His general equation multiplies each term by shape factor S, depth factor D, and inclination factor I. Shape factor scale with the B over L ratio, depth factor scale with D sub F over B, and inclination factors shrink the terms when the load tilts away from vertical. Add shape. S sub C equals 1 plus 0.2 tangent squared of 45 plus phi over 2 times B over L, while S sub Q and S sub gamma use 0.1. Depth. D sub C equals 1 plus 0.2 tangent of 45 plus phi over 2 times D sub F over B, and D sub Q equals D sub gamma with 0.1. Inclination. I sub C equals I sub Q equals 1 minus alpha over 90 squared, and I sub gamma equals 1 minus alpha over phi squared. Remember the auxiliary factor K, sub P equals tangent squared of 45 plus phi over 2. It appears inside the shape and depth terms to scale the corrections. Here is a quick comparison of assumptions. Terzaghi is for shallow, vertical loads and stops the failure surface at the footing. Meyerhof works for deeper footings, inclined loads, and extends the failure surface to the ground surface. Now follow the worked example with all numbers in place. We are given a strip footing with B equals 2.0 meters, depth D sub F equals 1.5 meters, cohesion 20 kilopascals, unit weight 18 kilonewtons per cubic meter, and phi 0. Step 1. Calculate the surcharge Q equals gamma times D sub F. 18 times 1.5 equals 27 kilopascals. Step 2. Substitute into Terzaghi's strip formula with N sub C 5.7, N sub Q 1.0, and N sub gamma 0. Step 3. Q sub U equals 24 minus? No, we should have 90. Weight 114 plus 27 plus 0 equals 141 kilopascals. Review the multiple choice options for this question. 1 is 114 kilopascals, 2 is 156.6, and choice 3 is 141 kilopascals, which matches our result. Understanding these bearing capacity methods ensures safe and efficient foundation design for every soil type. In summary, Terzaghi is great for simple, shallow, vertical loads, while Meyerhof is more flexible with shape, depth, and inclination corrections. Keep these formulas and factors handy for foundation design.